Hello everyone, welcome to summer internship program, and in this video practice I demonstrate you how to perform trigonometric leveling, but this time we use reflectorless mode. Actually, in the previous video practice I demonstrate you inverted stuff leveling. And inverted stuff leveling, we use it to determine relative height points A and B of this room. And point A is located in here, and point B is on the ceilings. You already know this. Applicability of this inverted stuff leveling method is also limited because sometimes point B could be very high, and our stuff the length of our stuff, even I extend it to maximum, is not enough to reach these points. Okay, in this case I cannot use inverted stuff leveling, so this time I use trigonometric leveling but reflectorless mode. So you already know what is the reflector. So this is our reflector. The pole mounted prism. This is our reflector. So, for example, I cannot use this reflector to identify the point B. For example, I cannot hold this reflector like this to reach point B, because this is practically impossible, and that's why I use trigonometric leveling, reflectorless mode. Actually, in the reflectorless mode, the point B, the wall, will be the reflector. So, electromagnetic radiation, which is emitted by the total station, is reached to the point B, reached to the wall, and reflected back to total station itself. Total station receives electromagnetic radiation, which is reflected back from the point B, from the wall, and it calculates the travel time. So total station calculates the travel time, and the total station already knows the velocity of the electromagnetic radiations. So by using two parameters, the total station microprocessor can calculate the distance, and this distance is our slope distance. Okay, so in previous video practice we have calculated relative height point A and B by using the leveling instrument, and we will get this value, and this value, relative height, is equal to 2.98. It's almost 3 meters. But today we will use trigonometric leveling, reflectorless mode, to identify the same height, and at the end of the experiment we will compare our heights, which we measure by using the reflectorless mode and inverted stuff leveling methods. Okay, So I already set it up my total station to point A. Before measuring the relative height, I will explain the theory of the trigonometric leveling, reflectorless mode. So before we go to the experiments, let me show you the scheme of the trigonometric leveling with the reflectorless mode. So this is our ceiling of this room, this is the ceiling, and this is the floor, and this is the point A, and this is my total station, it's here, and this is point B in here. So the measurement of the total station, the first I obtain slope distance by using the trouble time and the velocity of electromagnetic radiation, and azimuthal angle. So this is the azimuthal angle, and this is the distance. And if we draw the right triangle, this will be my small catheta and the vertical distance, and this distance is equal to this distance, vertical distance. Okay? To identify the point B, so I have to add to vertical distance height of the instrument. Height of the instrument I've already measured with this total station. It's equal to 1.532 meters. So the height relative height of point A and B is equal, it's very simple, vertical distance plus height of the instrument. Okay? And vertical distance is very easy, you know very well how to find. Vertical distance is equal to D, but it's better to write L instead of D because it's a slope distance, L, and L multiply the cosinus alpha. Okay, the cosinus alpha is azimuthal angle. So only thing we have to do, find L and azimuthal angle. Azimuthal angle, of course, we measure by using the two phase left and phase right, and we identify the final angle. And the same thing with the slope distance. We average the both slope distance and to find the final slope distance. Okay. Now I use the total station to observe L and azimuthal angle. So now I have to coordinate the point B. Actually, I can use the laser pointer to pointing point B. My laser pointer is here. But laser pointer is usually we use in the night time, but in a normal daytime, when the sun is shining, so we can use the telescope itself. So I turned off the laser pointer. So now I can read my first azimuthal angle and slope distance. So the phase left alpha, just alpha 1 equal gone, and the slope distance L1 4.502 meters, almost 4.5 meters. And now I change the to phase right, alpha 2 and L2. Okay. So now I change the phase right position. Now the total station is a phase right position. I collimate again to point B. Okay. So my zenithal angle of phase right is equal to 320.84 and 34 gone, and the slope distance is almost equal, but the error is 1 millimeter. It's here. This is no problem. So now I have to find the zenithal error. Okay. Zenithal error is phase left plus phase right minus 400 and dividing 2. Then I put the values. Phase left and here. Zero point 0.00115 bronze. Then I have to subtract from the first zenithal angle this value to find the final angle. And I have to also average 2 slope distance. Okay? And So final azimuthal angle is equal it's better. The final azimuthal angle equal this value minus 0.00115 tons. And this will be equal, so this will be equal this is our final azimuthal angle, and the slope distance, final slope distance equal, we just average this value and this value for 0.5 meters. Now I have all the final azimuthal angle and the slope distance, so I can calculate the heights. So let me clean. So now I can find the vertical distance. The vertical distance equal this equal L. This L. 4.50 multiplying cosinus this value gone, and this will be equal, this will be so now I calculated the vertical distance, and to find the final height is equal, we have to add the vertical distance, this value, 449 plus height of the instruments. This will be equal 2.98. So my height is equal 2.981 meters, which I calculated by using trigonometric leveling with the reflectorless mode. And I compare my previous value, which I obtained by using the inverted staff method, and this, my height equal 2.98 meters. Okay? You see, the two heights is almost equal, but we did 1 millimeter errors here. Okay, that means we can also use total station, trigonometric leveling, reflectorless mode to identify the relative heights of point A and B.